Hi guys, it's Miss Griffin. We're taking a look at making constructions of dilations. We're going to talk about scale factors of 2, scale factors of 1/2, and then centered at a point outside the triangle as well as centered at a point in the triangle itself. So the first step when we're doing this first problem here is to notice the scale factor. Sorry about the bells, I'm recording at school. Scale factor of 2 means that we are going to take this triangle and double it in size, so it's going to grow bigger, which means that we need to copy the length from the distance away from D. Because we're centered at D, we're going to start by taking our compass and connecting, this is step 1, point D through point A, and make sure the segment is plenty long, meaning make it nice and big here, starting at D, going through A. We're going to do that for each one, because what we're going to do with that is copy the segment like DA, DB, and DC to make the distance twice as far. That's all a dilation is changing the distance from the center of dilation. So what we're going to do now is measure the distance from A to D. Put your center on D and your radius on A. And swing a little smiley arc, or a baby arc, to show that you've measured it, just like you used to do when proving triangles congruent, or constructing congruent triangles. Now we're going to put our center on A and swing that same exact arc. So now we took the original distance and we just doubled it. This point now becomes A prime. So we're going to repeat that for DB and DC. So again, center on D, radius opened up to B, baby arc. Put it on B, swing across that line that we made, same distance, we just doubled it. And this becomes B prime. And last but not least, D to C. Oops. Baby arc. You have to have those original baby arcs in order to show that you've measured. Remember, we had to take off if you didn't do it on the congruent triangles. Still the same idea here. Now your last step is to connect A prime, B prime, C prime. So I'm going to use a color to do this so that it stands out to me because there's a lot of lines on this picture. Alright, so you see my pink triangle is triangle ABC with the primes, and it is twice the size, meaning it was dilated by a scale factor of 2. Same idea down here for example 2, except this time we're centered at point B. So instead of making lines from an outside point like D, we're making lines from a point on the triangle B. So we're going to connect from B to A, but extend it. And then extend from B to C so that we can double that distance as well. Alright, so we're going to put our center on B, radius on A, swing that baby arc to show that you've measured, and then swing it again from A. So we just took the length of BA and doubled it to make it twice as big. This becomes A prime. B to C, baby arc, and swing it again. So we have A prime, we have C prime, but now B prime, because it was the center of dilation, just like center of rotation, it would stay the same. So again, I'm going to use a color. I know that A prime, B prime is part of my triangle, so I'm just going to highlight over that line. And then same thing with C prime, B prime, and then connect my last segment. So again, we dilated the triangle to make it twice as big. If you need to, just refer to your steps off to the side or rewind the video so you can catch that if you didn't catch it the first time. Now on the back page, we're going to be doing a dilation not by a scale factor of 2, but by a scale factor of 1/2, which is slightly trickier, a little bit more lengthy of a process. So we're going to start up top here with a scale factor of 1/2 centered at D. Now remember, when we cut things in half in constructions, we do perpendicular bisectors. Right, bisector means cut in half. That's what we're doing here. We're centered at point D, so we need to connect each point to D. I'm actually going to do this in different color pens. Sorry, I don't have them over here. Let me go grab them real quick. Okay, so I'm going to do my first one, A, D, in one color. You might want to grab different colored pens or markers, something to help you out here, but it's got to be able to help you make arcs, so it's got to fit through those holes. So step 2 says construct the perpendicular bisector of AD, labeling the intersection point as A prime. So we're cutting this in half by using a perpendicular bisector. Remember, that's your fishy arcs. So again, radius more than halfway, center on A, go over halfway, switch, center on D, keep the same radius, and connect. Now, again, the point of intersection becomes A prime. So this point is A prime. Okay, now I'm going to pick up a different color pen and do B to D. Same idea. Connect, and then perpendicular bisector. Okay, so I'm doing this one in black pen. Center on B, radius more than halfway. Swing above and below. Your picture's going to get messy, that's why colors are helpful. And then connect through. So this time I'm looking for where my black straight line meets my other black straight line. So that's this point right here. And this becomes B prime. And then last but not least, we got to do C to D. I'm going to choose to do this in red. Again, pause the video at any point in time if you need more time to do your constructions. Open up the radius to more than halfway and swing. Switch to D. Swing. And then connect. Now again, where my red straight lines meet each other will become C prime. So now I'm going to connect my 3 pink dots to make my triangle, A prime, B prime, C prime. I saw a student of mine a couple years ago who chose to color in the triangle that she made so that it would stand out to her more because there's so many lines in here. So if you want to just quickly color it in, it might be helpful to you. So you can see that the original triangle, which I'll outline in green here, was cut in half, dilated by a scale factor of 1/2 to make the pink triangle. Now we are going to do something similar for example, well, I guess this is example 4, not 3. Can you change that for me on yours, please? This time we're centered at point A. So I need to still do perpendicular bisectors shrinking towards point A. So I need the perpendicular bisector of AB, shrink towards A, and then also of AC. We don't need to do it for BC because they're not going to shrink towards, they are going to shrink towards A, but we're going to be able to just connect those 2 points that we're making over here and here. Okay, so I'm going to choose to do blue and black here, starting with AB. And I'm going to turn my paper sideways. Sorry if that's obnoxious for the video, but it just helps me to do my perpendicular bisector. So I'm doing center on A, open the radius to more than halfway, switch and swing, and then connect through. So I'm looking for where my 2 straight lines meet, which is here. This becomes B prime. Then I'm going to do my other one in black from A to C. Radius more than halfway. C prime. And of course A is going to stay right where it is because it's the center of dilation. So now I'm going to connect And again, you can choose to fill it in, color it in if you choose to. But you can see our big triangle ABC was dilated by 1/2 to make the primes. Okay, don't forget to rewind the video if you need more time or just got stuck. Also ask your teacher for help if you need it. Adios, have a good day. Bye.